Hey guys, today we're going to work on some quadratic word problems, and we're also going to talk about the Pythagorean Theorem. Let's start off with the Pythagorean Theorem. This is question 11. It says, Mr. Green tells you that a right triangle has a hypotenuse of 13 and a leg of 5. She asks you to find the other leg of the triangle. What is your answer? So just to give you a little introduction into the Pythagorean Theorem, the Pythagorean Theorem works on right triangles only. This side across from the right angle is called the hypotenuse, and these other sides are called legs, the sides that make the hypotenuse. And usually people call them A and B and the hypotenuse C. The Pythagorean theorem says that if you square the two legs and add them together, you'll get the same answer as the hypotenuse squared. So when we look at this question again, and it says that the hypotenuse is 13 and one of the legs is 5, C would be 13, so we'll plug that in. One of the legs, we'll call it A, is 5, so we'll plug that in. And to find B, you simply solve this algebra question. 5 squared is 25. 13 squared is 169. To solve for B, first of all, you would subtract 25 from both sides. B squared is 144. And you would undo squaring with square rooting, and B would be 12. Now let's double check. Is 5 squared plus our newly found leg 12 squared equal to the hypotenuse 13 squared? Yeah, 25 plus 144 is equal to 169. So 12 must be the answer. Now, what about number 12? Number 12 says, two joggers run 8 miles north and then 5 miles west. What is the shortest distance to the nearest tenth of a mile they must travel to return to their starting point? So let's draw a picture. At number 12, you're running 8 miles north, and then 5 miles west. Now it says, what's the shortest distance they must travel to return to their starting point? So they're describing this distance here. So this is going to be our C. The right angle would be north and west make a right angle. C would be the distance that we're trying to find. So because this north and west and then the C value make a right triangle, the Pythagorean theorem will work. So A is, I should put the 8 over here. It looks a little confusing. A is 8 and B is 5, or vice versa. And to find C, the shortest distance to get back to their starting point, you just use the Pythagorean theorem. 25 and 64 is 89. The directions say to the nearest tenth of a mile, so when we square root both sides, you type this in a calculator. You hit second, x squared, type in 89, and we get 9.4 approximately. So that's the Pythagorean theorem. Now, the last question I wanted to try is basically a quadratic word problem. So this is question number 11, but on a different page. Question 11, right here says, the length of a rectangle is 7 meters less than twice the width. Now it's talking a lot about the length and not telling you a lot about the width. So in this question, we should make some let statements. Let's let x equal the width, because we know nothing about it. And then if we read that first sentence again, it says the length is 7 meters less than twice the width. Now a lot of people write 7 minus 2x, but if you have $7 less than somebody that, let's say, is $20, you would have $13. Because if you think about it, 7 less than something means you take that something, $20, and you subtract 7 from it. So the width would be 7 subtracted from twice the width. Now let's read on. The second sentence says, find the dimensions of the area is 60 square meters. The area of a rectangle, here's what the rectangle would look like, x, 2x minus 7, 2x minus 7. The three most important things you could do to help yourself out: make some let statements, draw a picture, and then make an equation. Area is length times width. So the area, it says in the problem, is 60. The length is 2x minus 7. The width is x. Now let's solve this. Let's clean up this right side by distributing the x. 2x squared minus 7x. Whenever you have a squared in a question, which is a quadratic, you try to get everything on one side of the equal sign. So I'll subtract 60 from both sides. And then you want to solve this equation. Now there's no GCF, and it's not a really easy trinomial to factor, so I'm going to use the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A is in front of the x squared, 2. B is in front of the x, negative 7. And c is the constant, negative 60. So it would be negative 7 plus or minus the square root of negative 7 squared minus 4 times 2 times negative 60 all over 2 times 2. This is 7 plus or minus the square root of 49 minus 4 times 2 times 60 would be negative 60, negative 480 over 4. Then we'd have 7 plus or minus the square root of, this would be actually an adding problem. So 49 plus 480 would be 529. Let's see if we can get lucky here, and 529 is a perfect square. It is 23. So 7 plus or minus 23 over 4. Let's break that up into these two answers. There's 7 plus 23 over 4, which is 30 over 4, which is 7.5. Or there's 7 minus 23 over 4, which wouldn't make sense because this is negative 16 over 4. Negative 4 cannot be the width. So I'm hoping that this is the right answer, 7.5. Let's check it out. Let's go back to the original question. X is the width, so that's 7.5. 2 times 7.5 minus 7 would be the length. That comes out to be 8. Let's see if this makes sense. Is the length twice the width minus 7, or 7 less than twice the width? Well, if I double the width, I get 15. Subtracting 7, I get 8. Is the area 60? 8 times 7.5 is 60. So let me know if you have any questions, guys, and have a great day.